first thing we got to talk about is this idea, and you mentioned it. You dropped a hint about this maximum design rainfall intensity and how a lot of times what we see is the maximum intensity kind of being this, what the stormwater guys look for, right?
That's right, Michelle. And again, as we also talked about, is there many concepts being borrowed and inserted into rainwater harvesting practice that may not even belong there. So the rainfall intensity tables versus design of roofs that often end up in rainwater harvesting designs. A classic case of a concept borrowed from a different area and applied to rainwater harvesting, and it's got very little impact on rainwater harvesting. So I think you had a table there, Michelle, that showed an hour 100-year return period rainfall intensity.
Yeah, and that kind of came from just some pretty common rainwater harvesting design recommendations in North America around, what you should design your system to handle. And it was often recommended that you use the 60-minute duration 100-year return, which is the largest rainfall event in the last 100 years, averaged over the course of a 1-hour time period.
You know what? It's actually a roof design criteria, and it's not well suited to roof design either. It's got really nothing to do with rainwater harvesting, but let's explore this for a moment. The roof design standards in Australia use 5-minute duration, 10 or 20-year return period for normal gutters, and only a 100-year return period for box gutters, which are internal gutters in houses, because if they overflow down the inside walls of homes and damage your property. So they've only used that larger return period. But notice they use the 5-minute intensity. That they only use 5 minutes because that's the lowest intensity rainfall that was recorded back then from our Bureau of Meteorology. Now we're recording 1-minute intensities, and they're now being used in roof design. Because if you think about how a roof behaves, and this has nothing to do with rainwater harvesting, but a roof catchment just happens to be part of rainwater harvesting. If you're designing your roof gutter system, this is what this is about. It's going to be the shortest duration peak event you can get that may or may not make your roof gutter overflow. This is what this is for. It's not rainwater harvesting per se. And then that is used to sort out the spacing of your downpipes, or downspouts, as you guys call them over there. And look, you can only buy a couple of sizes of gutter and a couple of sizes of downpipes at your local hardware or your trade store. So this concept of this is part of rainwater harvesting sizing, well, no, it's not. Is it part of roof design sizing? Yes, it is, within the limitations of the products you can actually buy. Mm-hmm. So what's going on here is your roof's going to be driven by a short duration behaviour of your roof gutter system's going to be driven by a very short duration storm, much less than an hour, probably around a minute, 1 to 5 minutes, likely. And all that's happening here is you're finding out whether or not your gutter is going to overflow and potentially damage your house. If your gutter overflows, some of that really rare event may not end up in your rainwater storage, but rainwater storages work on everyday events, not in 1 in 100 events, not even 1 in 10-year events. So you can see it doesn't apply, but it's important to know about. So all that's going on here is, say, 84 millimeters in metric, the downpipe size you can get over there, Michelle?
Oh yeah, really typical. Oh man, I don't down the gutters and the downpipes are pretty standard. To be honest, I don't even know what the size is. There's not a lot of options. The conveyance piping, when you might have to put in some PVC to redirect those downpipes to some tank. I mean, really, a 3 and 4 inch are 80 mil and 100 mil are kind of the common PVC pipe sizes that you're going to have access to in your hardware store.
So what's really going on here is these metrics will be used by your roofer, your roof plumber, to work out the spacing of your downpipes leaving your standard gutter system. So that's how that would work, and that's all about protecting your house and property from overflowing roof gutters.
Because there's some tables in the Uniform Plumbing Code that I've then seen repeated in very common literature on rainwater harvesting system design that I then tried to refer to in the book around this idea of how you should size your conveyance piping, your downspouts and your conveyance piping for this maximum rainfall design intensity. The other thing that we've talked about that kind of almost negates the validity of this approach is how water flows in the downspout in a down pipe and in your conveyance piping, which is not really full pipe flow. And you sent me a really great video that I want to pull up, and perhaps you can give us some commentary on that.
Yeah, that's while you're pulling that up, Michelle, I'll comment on that. Roof gutter systems and their downpipes or downspouts, they don't flow full. There's also entry and exit losses and friction losses and a whole bunch of things going on there. But essentially, they don't flow as jets, which the video shows, and they flow as a spiral around the outside wall of the storage of the piped storage. And so we're not talking about, say, a design for a water distribution system or even a storm sewer. In fact, the hydraulics of roof, gutter and downpipes and collection systems is very different to that of your traditional stormwater or water supply system or sewage system. However, some thinking about those quite different systems has been applied here. It's quite ironic that really not a lot of work has been done on sorting out the hydraulics and understanding the hydraulics of roof, gutter, downpipe, conveyance systems that might go to your storage tank. But it's not full flow, it's not steady state, which is where the assumptions from the larger systems come from. So if you've got your downpipe spaced at the right intervals, and if you're using these very conservative metrics to design your collection pipes, say if you've got 5 downpipes that are connected together into one conveyance pipe that may or may not enter your rainwater storage, the very conservative metrics are going to be more than enough to make your system work.
Yeah, and I guess is that really at the end of the day what students need to know about their downspouts and their conveyance piping is that the assumptions are extremely conservative. Use what's commercially available and it's gonna work.
I think that's the best advice, and I think the best advice of this part of the lesson, Michelle, is explaining to students where all this information comes from, so they can feel that, oh, okay, this is the background information that's going into my design. None of these things are critical and, life critical for the design of your rainwater harvesting system. You just need to know about them and work within those parameters.
Okay, I think that kind of covers it. The section I want to rewrite in the book.
Oh, I wouldn't get too nervous about it, Michelle. we should write
it bothers me.
I'm going to write a research paper on this. I'm going to set up some first principles hydraulics and actually work it out, because no one's ever done it. What a surprise.
Well,
it's actually quite complex. So
that's why I guess there's been all these really simplifying assumptions.